All right, now we're going to be solving systems using matrix methods. And there are two methods that we'll go through. This was interesting. The university presentation I was at last week, they specifically mentioned matrix methods, which isn't part of the curriculum. It's in the appendix of our textbook. I've been teaching it for years, so this lesson's typical. It's not a new lesson. So let's just start. We have a system of three equations with three variables, x, y, and z. The matrix of the coefficients, look where it comes from. It's the coefficients of the first equation, are 2, 5, and negative 3. They form the first row. And then down below, we have the same thing, but it's called the augmented matrix. And we have that vertical line where the equal signs go. And the right side of the equation, we have the constant, and we have 2, 1, and 3. That vertical line usually just gets omitted when we write it, and you'll see that I'll do that. But there we go. That's the first idea. We rewrite all the numerical information in a matrix. There's no variables, and there's no equal signs. And there's the augmented matrix, 3 rows and 4 columns. Okay. The first column is x coefficients, the second column y coefficients, the third column z coefficients, and the constant on the right side of the equal sign is the fourth column. Okay, so copy that down to your notes and then roll on. Okay. Very much the same process we're going to go through, but it looks different because there is no variables in what we're writing. We're going to use equivalent matrices, which is the same as equivalent systems, interchanging rows, multiplying by a non-zero constant, and adding and subtracting rows together. This is Gaussian elimination, and it's Friedrich Gauss from a couple hundred years ago, mathematician a couple hundred years ago or so. So elimination is actually Gaussian elimination, and normal distribution is Gaussian distribution. He's a famous mathematician. Okay. And the first method we're going to do is row echelon form. And I'm only showing the coefficient matrix here. We're going to be working with the augmented, but the idea here is that each row has starts with a 1. The row underneath starts with a 0 and then a 1. And if it's a 3 by 3, it's 0 is underneath a diagonal 1. If it was augmented, the equal signs, there would be more numbers to the right. And of course, they don't have to be 0 or 1. It's all the coefficient numbers that have to go to 0 and 1 like that. You'll see what I mean when we go through the example. So pause and copy. Okay, row echelon form. So I just showed that. We need to change, and I'm going to mark this up and then I'll erase. We need to change so that every first entry in every row is a 1, and each rows has more zeros leading than before. So we need all these to be 1s and all these to be 0s. Okay, that's the idea. So we're going to do things to achieve that. And that's called row echelon form. And I'll show you how that gives you the solution to the system, right? So this is the same augmented matrix we started with. So I'm going to erase that. Okay, so we need the diagonal of 1s with the zeros down to the left. Okay, so let me go back to stylus view and change colors. There we go. I need a 1 to start. I could divide by 2. I could take, and instead of numbering the equations, we call it row 1, and so on, like that. I could divide row 1 by 2, but look what happens. I have a 5. I'd end up with 5 halves, negative 3 halves, and a 1. I don't want to do that. As much as I can, I want to avoid fractions until the very end. So here we go. I'm going to do, instead of doing that, this is row 1, row 2, row 3. I'm going to take, to start with, I'm going to take row 2 and subtract row 1. Okay, so that's the first row. I'm going to take the second row and subtract the first row. I get 1, negative 7, positive 7, and negative 1. Okay, so I achieved a leading a 1 there. That's good. Now, the next 2 rows, I really like to get zeros. I could do this. and I'll use a different color. I could take two row twos and subtract three row ones. And I'm still just using row one and row two, but I'm doing a different combination, so it's allowed. I won't get the same equation when I do that. So that gives me a leading 0, -4 minus 15, -19, 8 minus -9, positive 17, and I have 2 minus 6, -4. Now there's final row, and I want a 0. Okay, I'm going to put the 0 there. I'm committed to getting that. So let's just see. I'm going to do, I'm going to do row 1 plus row 2 plus row 3. I'm going to add all three together because that gives me a 0. And that, oh, wow. I get a second 0, and I get a 3, and I get a 6. Okay. Look at how much we got done in this first step in getting this row echelon form. We have all the zeros we need. We just need to get a 1 where that -19 is, and a 1 where that 3 is in the last row. So row 1, we don't go row 5 or row 4 or whatever. It stays row 1, 2, and 3. So row 1, we're not going to change. So I'm going to go ahead and copy that down. Row 2, and we're almost done. So I'm going to go ahead and divide by -19. So I end up with 0, 1, -7, 17 ninths, and positive 4 19, negative 17 19ths, positive 4 19ths. And the last one, I'm going to take row 3 and divide by 3. 0, 0, 1, and 2. Okay. I now have achieved row echelon form. A diagonal of 1s and a triangle of 0s there underneath. It's actually time for the solution. From row 3, we know that z is equal to 2. From row 2, y minus 17 19ths times 2. So what I'm really doing is I'm taking the augmented matrix and I'm going back to the variables. That's negative 34 19ths, 38 19ths, so y is equal to 2. And then finally from row 1. And what we're doing here is called back substituting. And we did this when we did elimination method the last lesson. Okay, so from row 1, I get x minus 7 times 2 plus 7 times 2 is equal to -1. So x is equal to -1. And so the x, y, z is the solution, -1, 2, and 2. Now, this shouldn't be a surprise. I think the prior lesson, this is exactly the same system. I'm trying to remember. I'm just looking back. If it is, I think it is. Can't remember. It's been a while since I set up the examples. Yeah, it's the exact same system we solved in the prior lesson, this time using matrix methods. I find some students really like matrix methods. I would say on average, students make more mistakes with this than when it has the algebra in it, but it's really the same work. It just doesn't have the X, Y, Z. And we have lots of practice dealing with the variables, and this is new. So maybe we end up making a lot of sign errors and arithmetic mistakes. All right. Now, the Gauss-Jordan method. So Jordan modified, I think, what Gauss did. He goes to, instead of row echelon form, it's called row reduced echelon form. And we'll still be working with an augmented matrix, but instead of back substituting, we continue with the matrix operations so that the coefficients has this diagonal of 1s with a triangle of 0s below, like before, but also above, like this. Okay, so there's more matrix steps required to achieve this. The trade-off is that you don't have to do substitution. You can read the answer off from what you have in your matrix at that point. So pause the video, copy that down, and then we'll go on to example 2. All right, so copy this down. And go ahead and start working on your row reduced echelon form. You can roll the video. I'll begin by doing the augmented matrix, but pause and do as much as you can first and then start. Okay, now that you're ready, here's the augmented matrix. 1, -3, -2, -9, 2, -5, 1, 3, -3, 6, 2, and 8. Okay, row 1, I'm not going to touch in this step. I already have a 1 there, so I'm fine with that. Row 2, I give myself enough room here. I need a 0. So let's do row 2 minus 2 row 1s. So that gives me 0, gives me a positive 1, a positive 5, and 21. Oh, avoided fractions, that's good. And I guess I could add all 3 together, but I don't know. I'm just going to keep with that trend I had there. I got row 3 plus 3 row 1s. So that's 0, -3, -4, and -19. Now in the next step, I need to get some more zeros. And generally what you work on next is getting 0 here and here. You don't go for the 1 here. You go ahead and get the zeros first. Otherwise, you're going to end up undoing it and redoing steps and stuff. It's a really bad idea. So I'm going to take row 1 and add 3 row 2s to it. So when I do that, I get 1, 0, and I'm going to add 15, so I get 13. I'm going to add 63. Oh, actually, I see a better step. I'm going to do something different. I think this is better. I'm going to take row 1 and I'm going to subtract row 3. I like that. That's nicer. I like that. I don't get such big numbers. And row 2, I'm just going to keep because I got a 1 there already. And for this last one, I'm going to take row 3 and add 3 row 2s to it. So 0, 0. And so I'm adding 15 gives me 11. 3 times 21 is 63 minus 19 is 44. Oh, that's convenient. Okay, now not everybody likes this, and I'm debating whether to show it this way. But I'm going to go ahead because this is what I would do because I hate having to write extra steps if I can help it. I'm going to take row 3, and the first thing I'm going to do is divide by 11. I'm going to do that right away. And what I have here is the result of taking row 3 and dividing by 11. So for row 1, the next step, I'm going to take row 1, and I'm going to subtract what I've already done, which is row 3 over 11. So I'm going to subtract that. And I already have the answer down here, so it's not like I have to do it all in my head. I'm just going to subtract. I'm going to subtract 2 of them. I'm going to subtract 2 of them. Well, I'm going to rewrite that. I made a mess. So I want to be able to understand what I'm doing. It's going to be confusing enough. Minus 2 row 3s over 11. Row 3s over 11 right here, so I'm doubling them and subtracting. So it gives me 1, 0, and a 0. And now I need to be careful. It's not double 44, it's double 4, which is 8. 10 minus 8 is 2. And then for the middle row, I'm going to take row 2 and subtract 5 row 3s over 11. And so that gives me 0. The 1 stays. I'm not subtracting 5 times 11. It's 5 times 1, so that gives me the 0. 5 times 4 is minus 20, gives me 1. Okay, so that's row reduced echelon form. And this simply means that x is equal to 2, y is equal to 1 and z is equal to 4. And there's my answer. Okay. So you need to practice this. We'll do one more example. Wow, I'm looking at my notes. I have a lot of steps. I might ignore that. Hopefully it'll work out. Here it is. Go ahead and start. I'll begin in a minute. Some people are really good at seeing patterns and making this quicker. Let's see how you can do. All right, once you're ready, you can roll the video and I'll begin. So augmented matrix first. Here we go. The first one seems good, so I'm going to keep row 1. Row 2 minus 2 row 1s. Row 2, sorry. And row 3 minus 3 row 1s. So I feel like I'm not being very clever, but, it'll work. So keeping the first row, no work. Second row, the next row, I'm going to take and subtract 2 the first row, so I end up with 0, -3, and I'm subtracting 2, so -1. I'm subtracting 24, so -19. Ooh, some ugly numbers there. Row 3, I'm subtracting 3 row 1s, I get a 0, -5, -5, and -35. All right, I'm going to stop looking at my solution. I don't like it. What I'm going to do in the next step is, for the second row, I'm going to take row 3 and divide by -5. Okay, so I'm going to go ahead and do the middle row right away. Let me get the window. The dogs are barking next door. Okay, so I'm taking row 3 and dividing by -5, and that's going to become my new row 2. Now, my new row 1, I'm going to take row 1 and subtract 2 row 3's over -5. So I'm going to have the 1. I'm going to subtract 2, gives me a 0. Subtract 2 gives me -1. Subtract 2 gives me -2. Okay. And for row 3, the new row 3, I'm going to take row 2, and I'm going to add 3 row 3's over -5. So 0, 0, 2, and I'm adding 21 gives me 2. And I think I have a mistake because I'm not matching the answer. Let me just double check. Row 2 plus 3 row 3's. Yeah, 2, 3, 2, and 2. And it's a bust. What did I do? I'm supposed to be getting 2, 3, and 4 as my answer. And I'm already showing a Z of 1 instead. So I feel like I made a mistake here. Oh, I'm going to pause the video and figure it out.